All right.
Well, David, thank you so much for helping my project. Can we start off by you saying a little bit about yourself?
Well, I'm retired from NASA. I'm an engineer. Worked in NASA on space station on testing all that and making sure it was maintainable, and then got into advanced development office at NASA Johnson Space Center. Worked on some of the early efforts to get us back to the moon on constellation planning. I was lead for a lander development planning team pre-constellation. Uh, Ended up retiring when about the time the shuttle was retired. I took a retirement and have worked in trying to make some of this happen ever since then.
Uh, it's interesting you mentioned the space station. I know we're going to talk about the moon, but today is kind of a special day, being the 20th year anniversary of continuous habitation, right?
Yeah, yeah, that's right about now.
November 2nd, 2000 was the first
I
crew.
I think so. Yeah, we had a launch before that, but it wasn't really crewed before that permanently.
Um, so kind of a digression. Sorry to catch you off guard. I know you asked me what we're going to talk about, but um, I mean, there's talk about the space station going into private hands in 2025. You know, the current NASA administrator, Bridenstine's like, eventually the space station has to be replaced, it has to go away. I mean, what are your thoughts about that?
Well, I think there's going to be a time when it can no longer be depended on to support regular human missions. I'm not convinced it needs to go away at the time that it reaches that age in its lifespan. I think actually it should be considered to boost it to a very high orbit, parking orbit, where it doesn't have the atmospheric drag that it does at the lower orbit that it's at, then left something like a World Heritage Site for future generations to be able to go visit. Maybe they can't go inside, but to be able to go take a tour around it and be able to see it. It was a lot of mass was put on orbit and a lot of expense to put it up there, and it's going to be a difficult job to take it into pieces and re-enter it safely. So I think that would actually be a real good thing to go ahead and do with it, and it could be a little bit of a preservation of history, like the Apollo 11 landing site, and left there so future generations can be inspired by it. I mean, other things that could be done with it too that would negate just having to throw it away would be being able to salvage parts of it, work from it, and use it as kind of a dock for some other pressurized vehicles, pressurized modules, and so forth. So I would not say just go deorbit it.
What would it take to actually put it in that higher orbit? I know they do regular reboost with like the Progress, um, you know, rockets right now. Is that enough to get it to that higher orbit, or would something have to be developed to do that?
Oh, I think you could do it with something like that. Of course, you'd have to reach the agreements with the international partners of it that that's what they'd all want to do, and either include them with it, or even in some form, if they wanted to drop out of it, there could be some changes made to configure it a little differently. But it takes some time there, and it could be a way of testing some other propulsion systems too. You could attach something to it and test out some things like some of the electric propulsion or something.
Yeah, I guess the biggest risk are maybe it's starting to tumble, making sure the gyroscopes are still good, and then losing power and communication. As long as you had
Yeah,
those, it
yeah.
should
If you
be
if you
good, right?
kept if you yeah if you kept basic control of it with a control module that would keep it stabilized. I mean, it actually is, as long as you could maneuver it to avoid debris if necessary, really probably could be allowed to tumble if you weren't planning to dock with it in the future. Just wanted to have it where future generations could see it. But of course, I think it'd be better to have it stabilized.
Yeah, a stable space station. I think that's. that's the way to go. But when did you find out we were planning to send people to the moon in 2024?
Well, that's kind of a funny question, Nathan. I was with a team that was working on having some options for the next administration after Obama's term ended, and we put together a number of options that we looked at, actually kind of centered on one that we really liked. We called it the Evolvable Lunar Architecture, and that was bringing commercial companies in to be able to do collection of the lunar water and use that as a supply for making propellant for being able to do Mars missions. So we had that plan back well before it was really announced. Oh yeah, we're going to go back for 2024. I went and presented that plan to the NASA transition team at request of one of the members that was on the team that was another one of my colleagues, and stopped by that morning to present it to a congressman named Jim Bridenstine, who later became the NASA administrator. So it was no real surprise to see it, coming about. I can't say I remember the actual date that it was publicly announced, but those of us that had been kind of working on trying to make it happen were pretty well aware of the plan before it was public.
Jim Bridenstine was confirmed in the Senate right along party lines, and it was very contentious. But I think he's performed beyond everybody's expectation as NASA administrator, and I think he would have a lot of support from both sides today. Do you think that's true, or is that just maybe a naive opinion?
I think he's potentially going to be able to stay on if the election goes that way. Of course, being on the eve of the election, we really don't know. But I think he's been a great NASA leader. A lot of people didn't think he had the experience in space, but he had experience in aircraft, and there's a lot of operational experience that carries over from aviation to space, and he had the congressional understanding of how everything worked there too. So nothing says that the best leaders of a technical agency really have to be technical. They need to be good leaders.
But I wonder, in your presentation interaction with him while he was still a congressman, would you have expected from that interaction for him to be the NASA administrator that he turned out to be, or has he really grown a lot since then?
I think he turned out pretty much like I would have expected. Yeah, and that was. I think it was right about that time that there were the first hints that he might be considered for that. Of course, it took a long time for that to actually happen. But I've been very impressed with how he's handled everything and trying to manage all the pieces on here. Now, of course, we've got the date of 2024. I would probably have said, let's go to a lunar site that we think would be good for economic development, and do the robotic scouting and precursor type missions and really find the best place and focus more on that initially, and let that drive the eventual landing, and not necessarily a particular date being set for it. If you look at the Evolvable Lunar Architecture that we proposed, which basically that's available if anybody wants to go look for it. If you do a Google search for Evolvable Lunar Architecture, space.nss.org, media, Evolvable Lunar Architecture with dashes is the whole 100 and some page report. But personally, I would have advocated doing that robotic prospecting kind of in parallel with doing a landing, not necessarily in a polar region, but a polar capable lander and it's a lot less stressing to take that lander and land it in a more equatorial or mid-latitude region. You have a lot more margin for propellant and so forth. So I would have tested those capabilities with humans kind of in parallel with that, and then let that lander get some experience and less demanding approaches, and then start using it at the poles when we're a little bit more certain of what the conditions are and being able to do the economic development there, the understanding the characteristics of the ice and what it takes to mine it and collect it and operate in that region. So I would say let's do it in a way that's sustainable to begin with, rather than try to rush to get there by a certain date with people and then maybe have to redesign a lot of stuff to make it really sustainable in a way that you can basically reuse all the vehicle, uh, not have to uh, leave descent stages behind on the surface. Start off with a more reusable approach to begin with.
Yeah, I mean, Bridenstine likes to talk about you have technical risk and political risk, and he's like, we know how to solve the technical risk, but the political risk are a lot of it's schedule based. You know, if you push out the schedule too much, then you may not be going anywhere.
Well, that's definitely one of the risks, and that's one of the things that we looked at in the study was the integrated risks, all the different kinds of risks that you get from doing a project like this, economically, from an investor standpoint, from the technical risk, safety risk. Try to balance all of those risks in a way that makes the whole program most likely to succeed. And say the way we had proposed doing this in the 2015 report was really basically to keep NASA focused on going to Mars, but let private industry go do the work of getting down to the surface of the moon and doing the resource recovery process or resource prospecting and the mining and produce the propellant. And NASA just make a commitment to buy propellant to be able to get to Mars.
Hey, it seems like they're sort of on that path. I mean, between the commercial lunar payload services program
Mm-hmm. Mm-hmm. Yeah.
and then buying material that other people get on the moon as just to create that precedent. It's not really economically
Right.
valuable, but maybe legally valuable.
Oh yeah, yeah. That's the whole idea of collecting or purchasing and having transfer of ownership of regolith, is to be able to demonstrate that from the legal and business perspective.
Uh, you know, as part of the commercial lunar payload services program, Astrobotic is landing their probe on the moon next year. And I bought a DHL moon box that will be going to the moon. And I'm planning to send this micro SD card. It's 1 terabyte.
Okay.
Hopefully, future generations will have this magical technology to be able to reconstruct what was on it. But I'll put a copy of your evolvable lunar architecture on it. That way,
Oh, that'd be great.
future generations will. Well, no, I'm putting
Yeah.
this video on it as well. So, and if you have anything
Okay.
else, I got plenty of
Yeah.
room. 1 terabyte. So
All right. Well, let me think about what else could maybe go in that sort of
maybe
archive.
the winners from the design the space settlement design contest,
The competition.
the
Yeah.
competition. Yeah.
Yeah. There's a space settlement contest that National Space Society runs, and there's a space settlement design competition that's also a project of NSS. But the competition is very structured in asking high school students how to build a specified settlement meeting a specific set of requirements, and they've got in a regional 20 some hours to come up with a 50-page proposal simulating what it would be like for working on a space station proposal if you're with Rockwell International or Boeing or a big company like that, but it's in a very compressed schedule. Teaches the basics. So yeah, we could put a presentation on that we did this last August,
That
July,
that,
actually it's the end of July.
that would be neat. Well, my original plan. So Doug Laverio had that lapel pin where he was counting down the days in a 2024, and he had his hero of the day where he was highlighting the NASA employee each day that's helping to contribute to our 2024 date. So that's what got me started on this these interviews. So regardless of what happens, I plan to interview somebody every day into the end of 2024. It's just the conversation becomes a little bit more complex whenever there's not the moon landing then. But um, most of the people I've interviewed between December and the end of March were non-space people. And the majority of them didn't know we were going to the moon in 2024. Do you find that surprising?
No, I'm not really surprised. It's not necessarily the mainstream media to really create awareness of things like that. I mean, and just going, yeah, I think there's a lot of excitement just to go and get humans back on the moon from just the kind of the human aspect of just showing the ability to do it. But that misses the real reason for going there, which is to be able to go there and access the resources that are there and use that to be able to build new capabilities using there's everything almost that we need on the moon to build like space-based solar power, the satellites that could provide energy back to the Earth, start with providing space-based power for the lunar, so the lunar outpost, but then it started extending that space to space and then space to ground and remote regions and be able to do water purification in areas that don't have clean water and don't have the power to be able to do distillation and things like that. There's just so many things you could do that could stimulate the economy and make life better on Earth. And that's the message that should be going out. It's not that we should be going there just to, show that people can be there. It's going there to be able to make things better, to create real value from the resources that are there, to reduce the fighting for scarce materials that we have on Earth that invariably, people get into scrabbling about, getting these kinds of materials. That's really the message that should be out there. That it's people think it's horrendously expensive to go to the moon, and it has been historically, and it will be if we keep doing it the same way we've been doing it before. But it's like we throw away 98% of the vehicle and use it only one time, like in Apollo. It would be like buying a 747, custom 747 to fly it to Australia, to park it there because there was no way to refuel it, and having to take a small private jet out of the cargo hold and use that to fly back. Nobody'd be able to go to Australia. But when you can refuel that aircraft and fly it back and go back and forth and create that infrastructure with transportation, power, and communications, then the cost can go down dramatically, and it will be affordable. And that's kind of what we're seeing happening now with commercial getting involved with space in a way that they really couldn't before. And we had commercial companies, but they were all doing cost plus contracts with NASA. That NASA said exactly what they wanted the vehicle to do, and it had to be designed exactly to those requirements or have waivers and deviations to make little changes. And if it ended up taking a lot longer to design it and develop it, well, they just add that to the cost of it plus a fee and a percentage for going over. It doesn't really provide a real incentive to be able to do anything cost effectively. So
In fact, it provides a incentive for just the opposite. Cost
yeah,
effectiveness would be bad business.
yeah, actually, it's a negative incentive to be able to do anything really. effectively. And so that's, I think, why we've not had exponential growth in space development. Is it's just you try to get the maximum performance out of the vehicle. You design it for the absolute minimum weight. You try to get it to do one vehicle do everything. It gets too expensive to make any changes to it, and it's a disincentive to try to make really modifications and improvements or start over and try another thing again, because it takes it's taken most of a career span of people to develop a launch vehicle and operate it, and by the time they're ready for a replacement, most everybody's retired. And it would be like Intel trying to make computer chips, and if they had to start all over with all new people by the time they go from the 8086 to the XT, or go to the 286, 386 Pentium, if you were starting with all new people that didn't have the experience of doing the previous generation of a chip, it would not have developed as quickly as it has. And that's almost what's really happened with the space industry up until very recently, and now that's starting to change.
Absolutely. I mean, between Blue Origin, SpaceX, the 14 commercial lunar payload services companies, Virgin Galactic, there's and Rocket Lab. I mean, gosh, who would have thought New Zealand would be the only other country in the world that would have a private capability to launch things into orbit?
Yeah.
And in fact, New Zealand doesn't even have a national program that's capable of doing that.
Well, I believe it's an American company operating there, though, is it not?
It started in New Zealand. It became American in order to be able to do governmental contracts with the U.S. Government. So, but Peter Beck is most certainly New Zealand, a New Zealander.
Yeah. Okay. I just remember seeing that they did have the American company on that.
Yeah. No, it's kind of amazing. And so what do you think about us returning to the moon? It sounds like you're an advocate, but what do you think?
Well, yeah. Well, I think if we're going to go to Mars, learning how to operate on a different surface, the moon is a good way to learn to do that. It's only a few days trip there, a few days trip back. You don't have to wait for a window to launch, once every year and some odd. There's something goes wrong, if you need supplies, it's just a whole lot easier. So it is a good way to gain that experience. And they say you can actually leverage the resources that are on the moon to be able to get to Mars more effectively. I personally would like to see the moon continue to be operated for what it has to offer, and not used, as some people call, a stepping stone. The stepping stone, you step on it and then you move on to the next place and you leave the stepping stone behind. I think that's one thing we want to be careful not to do. The same thing with the low Earth orbit, and like the station. You don't really want to abandon low Earth orbit just because we want to go further out.
What do you think it would take to build a city on the moon?
Well, one thing is, there's a lot of things on that. I mean, there's the technical aspect of it. There's the financial aspect of how you do something like that. I'm sure there's going to be political and legal types of frameworks that need to be worked to do that. I mean, from a technical standpoint, I think getting there and understanding what the materials are that are available to be used to construct the facilities with. I don't think you can realistically plan to bring it all with you, even if you have a Starship and that kind of capability. Starship would allow you to bring more mining equipment to be able to utilize those resources quicker and with less flights there. But I think learning about the environment, getting the power, getting all those infrastructure things uh, worked out is key to being able to get that to happen. Having the robotics to do site preparation and do as much in advance before people get there. Having facilities, some kind of small housing. In the design competition, we refer to a construction shack. Uh, having a place to stay while working on the overall architecture of it. I think it's going to take all kinds of industries that we have presently terrestrially. I don't think it's going to be just an aerospace industry kind of initiative. It's going to take companies that have chemical processing experience and power generation, uh, having the mining type experience, just even supply chain kinds of companies, and all the products that are needed to be able to support that food agriculture companies. Uh, it's going to take that level of I guess capabilities that we have on Earth and making those adapted to being able to develop the lunar kind of large scale habitats, you know, cities, settlements, whatever consider them. Probably start with some small experimental facilities to just learn how to do the processing of the materials. You've got 16G. It's not anything we have a lot of experience with. How fluids flow in 16G, how granules of say regolith flow if you're trying to do processing. It's all different. Fire behavior may be completely different in 16G than it is in either 0 or microgravity or 1G. So it's going to take a good bit of effort.
Now, some of the people I've interviewed, not many people, but it took me by surprise. They said we shouldn't go to the moon because we messed up the Earth. Why would we mess up the moon too? I was just wondering what you thought about that point of view.
Well, I understand that kind of a viewpoint, and yeah, humans have a long history of managing to kind of trash any place that they go to. But we're learning. I think there's things you can do, maybe moving some of that heavy industry off of Earth, like Jeff Bezos was saying. Do things that reduce having to tear up the only place we have that you can live without having to have bring in air and provide pressure shells and do that. Make the situation where you preserve the environment here and try to take steps to not do things like leave a lot of debris around, and we're doing with the orbital debris. It's one of the things I'd rather see us have fully reusable landers rather than leaving spent descent stages every time you land something. So those are good examples of how we could end up leaving a lot of trash around. So thinking ahead of time about how all those can be managed is important.
Of course, I can't. The phrase "one person's trash is another person's treasure" comes to mind. I got to imagine that some future generations might not look at those things as trash, but as valuable resources to be reclaimed.
Well, they could, yeah, and as long as you have some operation that does that, you've got refined metals and tanks and things like that. So there are things that could be done with it, but that's all part of what should be planned in trying to do these kind of developments, and don't just start setting things up kind of without any thought about it. Having a company that does architectural master planning and looking at how is this first construction shack or first set of landing facilities, how does that grow into a pleasant kind of kind of a habitat overall. I know there's a company, Skidmore, Owings and Merrill, that's been looking at the architecture of how to do lunar design and in the master planning. Maybe the best place to set something immediately is because it's got a peak of they call eternal light. It's not totally eternal. It has some gaps in coverage, but you start putting something up there, those are going to be the places that you really need to plan your whole community around if you're going to be setting something up in a South Polar region.
Yeah, absolutely. And back to that idea of messing up the moon, that led me to thinking, what would be the most catastrophic thing that we could possibly do to the moon? And the thing that came to mind was the idea of, you were talking about those peaks of eternal light. Well, you also have those craters with eternal, permanently shadowed areas.
Mm-hmm.
I was just thinking the worst thing we could do to the moon could be kind of causing one of those crater rims to collapse and exposing potentially this resource to the sun and kind of seeing it disappear right before us.
Yeah, it wouldn't necessarily take a lot to lose a lot of those resources if we're not careful.
Yeah, and I also think thinking of them as just being frozen water ice might also be missing part of the value of them too. I mean, there's got to be lots of other material that's embedded in that water ice that might be interesting to study.
Oh yeah, yeah. Well, that was one of the reasons I did a follow-on study after the Evolvable Lunar Architecture, was because that that study really only focused on water, and I think in order to really make all this economically viable, you need to look at all the resources combined. The byproducts may be worth as much or more than what the first thing is that you're really setting up a mine for. So that's part of why I would say, you know, don't race to get there with, the boots on the moon right away, but think out what's there, how can you use it, what's the best way to do it. You could easily end up optimizing all your processes around water, and then all you've got is everything else that you should have been thinking about getting to begin with, just kind of now being in a state that's harder to do anything with. Your processes aren't designed for.
Yeah. And well, if it was safe and affordable, would you go to space?
Oh yeah, yeah, that would definitely be something I would do.
How far would you go? Are we talking about an orbital trip or a week or two to the moon, or would you like go to Mars?
I think I'd probably limit it to maybe going to the moon.
And how safe would it need to be?
Well, that's a relative term. I mean, I don't know that I'd need it to be any safer than maybe making a climb to Mount Everest. I'd probably consider something like that would be an acceptable risk.
That seems reasonable, especially considering I hear the top of Mount Everest is kind of crowded with all the people going up there and what have you.
Yeah,
So,
a lot of people will accept that level of risk.
um, well, I really appreciate your time. Is there anything else that you wanted to talk about that we didn't get to?
Let's see. Um, yeah, I think just how to get the word out to get people thinking about not just scientific exploration, but it's time to do development. It's we still need to do science. I'm not saying don't do the science, but we've kind of made space synonymous with exploration, and we've been exploring it for a long time. Let's start figuring out how to make it serve humanity and make life better for us on Earth. That's my engineer's view of it. I'm an engineer, not a scientist, but and It's how do you take the science that you have and turn it into something that helps create a better life for people. So I'd just like to see us talking about, when we say space exploration, at least say space exploration and development.
Yeah, infrastructure development. I mean, right now, doing anything in space is cost prohibitive because there's zero infrastructure in space, pretty much.
Yeah, well, with having that infrastructure and having commercial capabilities, there's a thought of, it's hard to even do the science, but if you have more routine access and capabilities and reuse, you can leverage that to enable greater science. So we kind of use the term commercially enabled science. But
Yeah, I
there's
mean,
there are different methods of looking at things, from pure science and just understanding the physical processes and chemical and geologic processes, from being able to, say, assess how much resource there is in a particular area and whether it's economically viable to get that resource out and be able to utilize it. So it takes a different approach, and so that's one of the things that I think that message needs to go out, and get people to be more cognizant of the kinds of benefits that this can really bring, not just to one or another countries, but I think globally it it can help improve life all over by having better access to the kinds of resources that are there.
yeah, I heard a stat. I'm not sure the numbers are precisely right, but order of magnitude it should be right. About 1/700th billionth of the sun's energy falls on the Earth. Which
Yeah.
means that you have a lot of energy escaping that, I mean, if we could just create like, space-based solar power, you could reclaim so much more. I mean, you know, as much energy as you want. If you could build the solar panels from the materials on the moon, you wouldn't
Absolutely.
harm
Yeah.
the Earth. And
Absolutely. And you don't have the rocket plumes trying to launch it all from the Earth. So you might even reach a point where it's cost effective to launch all this stuff from the Earth. But do you really want to have the mining operations on the Earth to produce that equipment? Do you want the rocket exhaust plumes and whatever that impact is, if you can avoid all of that and get it from the moon?
right, and you don't even need to have the exhaust plumes necessarily on the moon, because you probably could use like a mass driver or railgun type of.
That would actually be better to do that, because there will probably be some sort of, should we call it a very thin atmosphere of exhaust plumes if we start getting to where we're doing this all the time at the moon. So having other forms of transportation to get the materials off the lunar surface, whether it's a mass driver or tether, hoist, elevator, whatever, all those things ought to be thoroughly investigated. And not to say one or another is the best solution, but how do you utilize everything that you've got access to and capabilities? It's like your toolkit. You might favor the screwdriver, but there's other tools in the box.
Or sure beats the back of a shoe to try to hammer stuff in.
Right. Okay.
Well, I really
Well,
appreciate your
Nathan,
time. Yeah.
Yeah. All right. Appreciate it. And glad you're doing this project. It's interesting effort you're making, and sure appreciate it.
Well, thank you. I appreciate you being available today. I haven't missed a day yet, and I'm committed to not doing that, even if it drives everybody I know up the wall.
Okay. Real good. We'll talk to you later then.
Okay, take care.
Bye.
Bye-bye.